Hot water is really important. It is civilization. It is sanitation. We don't have it, life is pretty miserable, especially if you're responsible for large numbers of people having hot water. Then it's your problem, like extra emergency. And it can be very difficult to get service and to get that arranged or for changing a water heater on short notice. And it can cause flooding. Water heaters are really heavy and it's hard to get them up and down stairs and stuff. So there's a lot of issues, and the plumbing is complex. And there's issues about making them live longer that make the plumbing more complex or maintaining them while you're keeping them. So going from the outside in, if we look at an outside of an example, in this case, an apartment building, which is sort of a worst case complexity situation, which you can apply to your own situation as you see fit, although obviously your situation may be different. But you may not want to have a tanked water heater, but I prefer them. If you look at the beginning where the water pipe comes into the house, there's usually a beater or a valve or a shutoff or something. It could be in the ground or it could be right at the edge of the building. There's often a shutoff valve and a pressure regulator. And it's good to have a pressure regulator so that your water heater and your system is not overpressured, especially at night. Unfortunately, in the existing situation that I described, the apartment building has a fire sprinkler system whose flow pressure is based on not having a pressure regulator. So it can't be used on the cold water input of this building. The other problem with a pressure regulator in the front of the building is that they get stolen. And they're made out of brass, and in the larger sizes, they're expensive and use more exotic brass. So in one case on another building, we had 2 pressure regulators stolen, and they sawed the pipes off, and so there was no water for a medical office. So in that case, they were 1-inch pipes. So I substituted 3/4-inch pressure regulators because they are available at Home Depot, and they're half made out of plastic, and they use a lower grade of brass, which is less desirable for the drug addicts who steal them, who take them for their scrap value. And therefore, it still worked okay, even though it's probably not code, but it worked fine. And then also a guard was placed around it. In this case, it was a gopher cage that was adapted to make a cage around it. They do make some fancy cages that you see that are usually green coated wire, but they don't always fit the scenario that you have. They're darn expensive. So good luck with that. But meanwhile, you've got the water coming in the building, and you could, in front of the water heater itself, place a pressure regulator inside where it's safe. And the same goes at that location if you wanted to filter your water before it comes in the water heater to keep particulates out of the system. But on the other hand, you may want to put this big filter on the exit of the water heater because the water heater itself produces a lot of debris because the oiling of the water produces a lot of minerals, which are a source of a lot of problems. They get into the valves in the system, and then the valves of the showers, your toilet, and everything get contaminated and cause all kinds of plumbing problems and more work and more money. So putting a filter on the opposite side of the water heater could be really useful. But staying with the theme of starting from the outside of the building in, as we're talking about debris in the tank, there is a method of draining the tank periodically to try to flush out debris. Unfortunately, the water has to go someplace. So there's 2 ways to get it out that might be arranged and that I think is good. One is to have the big pipe that comes out of the water heater to have it piped to the outside, a large flushing valve. And there's also usually a drain that comes with the water heater that has a little hose spigot on the bottom. So you can drain the bottom of the tank and you can try to drain that debris out and flush it out. And so it either goes outside or it goes into some sort of sump pit with maybe a sump pump that pumps it outside. But on the top output of the water heater is also a flush point that you can also pipe to the outside. That would be if you want to back flush your entire faucet's hot water system because it is contaminated with some crud. And in that case, you have a loop that goes all the way around the building that supplies and then returns to the water heater. So you have valves in there so that you can supply the hot water to the building backwards through the smaller pipe that's supposed to be the return. And then you flush it backwards to the bigger pipe that normally exits the tank. This allows large particles which got caught to be flushed because now the flow is going in the direction where the pipes go bigger. That does require a big valve on a big pipe and then a big pipe that goes outside to flush somewhere. The plumbers have to understand that you've rigged the system for this purpose. Otherwise, typically they'll back flush the system by going in someone's apartment on the other side of the building and running a hose into their apartment underneath the sink and tapping into the system here in order to flush the system backwards, which is really disastrous because it could cause all kinds of flooding and you're inconveniencing the tenant. You're failing to use the return pipe that you already have, that you could have just used down to the basement by throwing some valves, like you were a guy who works on a submarine or something that knew about the valves and did all your valve turning. But they don't know about the valves and they don't really know why you were doing it, why they were set up. So you got to have some labels on things. My favorite labels are unglazed tile that you write on with a pencil. But that may not be available. I'm not sure what the hell to use. Official metal glazed ones would be good, but you kind of got to put a lot of information on there. So somehow you've got to explain what the hell this thing is for. Otherwise, the plumbers will probably remove it. That's what happens to me. They go, "What's this extra thing? We should remove that." Because they just have one way of doing it and they don't really think about it. So there's that issue. So those are two pipes that go outside from the water heater, either a sump or a back flush valve or both. Now there's two other pipes that go to the roof. So you've got an outside pipes on the roof. One of them is the combustion vent. That becomes important, especially because you got to calculate the size. And if you try to use two water heaters, then you've got to check the charts of the codes to try to make sure you can have enough British thermal units of two machines to do the deed with two water heaters. And the advantage of two water heaters is that they weigh a hell of a lot less. And then it's easier to get them up and down the stairs and install them, even with your PowerLift brand special dolly that has a jack built into it that can lift water heaters all the way back into the back of your truck if you want it. And so I think it's called PowerLift. I forgot right now. But anyway, it splits into two pieces and it has a lead acid battery and you have to charge. And it weighs like over 100 pounds itself. So it's a pretty big nightmare to move, especially a 100-gallon water heater. You could split it to 250s. That would be great. But you got to have enough combustion air vent. And so there's a charting system and the length of the vent, and you've got to connect it with some sort of a T or a Y. And it's kind of ambiguous since they all talk about T's and other people talk about Y's, but it's not totally, a Y is an angled connection. It's not totally clear which one you've got to use or what, but it seems like Y's would be better. But nonetheless, the code shows a picture of a T. So once you've got that pipe to the outside of your building, there's another pipe that on that system that loops all the way around the building. Usually you have the return line often is in the attic anyway. Or you have pipes in the attic that represent the highest point that your hot water system goes. And the importance of that is that you take a T off that thing and you go vertically from the highest point somewhere in the attic. You go through the roof, you come out with some sort of valve where you can open that up and you can evacuate all the air that's in the system and maybe even some of that crud that got in there from the water heater. But most importantly, the air. Because when there's air in the system does all kinds of crazy stuff that you can't understand, and everyone complains and calls the plumber and doesn't know why. And this can go on for like months where people are being burned in the shower because the water heater shower valve mixers don't work right because of the air in the system. So it's a big problem. So you've got to go on the roof and open this valve and just drain it for a while until all this sputtering and popping of air is done. Unfortunately, that water is really, really hot, and it isn't super great for your roof to be shooting this geyser boiling hot water on it. So ideally, you would pipe that shoot off valve down to one of your downspouts or someplace where it goes, where it doesn't trash your roof for being so damn hot. And there's also the problem of getting on the roof to do that, and also the problem of your plumber not knowing about it. So we're back to the signs downstairs telling them that they've got this thing upstairs on the roof and telling them how to get up there and to do that, especially after you work on the plumbing. Because when people work on the plumbing, they let air in the system. So now you've got air in the system. And especially after you flush the water heater, now you've got air in the system. So you've got to do that. Otherwise, you have a nightmare of people constantly calling you with stuff going wrong. So in the past, I put them up there and no one knows about them. And then I didn't finish piping things out and I didn't put up signs. So a lot of this stuff didn't work because I didn't finish piping them outside or piping them to a distance. And I didn't put signs all over it. And also, it was really hard to get on the roof for various reasons. And so there's got to be the equipment and the ladder with a lock on it or something. That's what you need. I'm just telling you what you need, ideally. So then there's the water heater itself area, which we were talking about splitting it into 2 heaters, which I'd like to do soon myself. And there's a lot of controversy about that, but I believe the best method based on reading is that you tee off of the 2 water heaters exactly in between 2 of them, the distance of pipe that connects them. You connect them in parallel, and then you tee off of them. In other words, they both feed equally off through this tee. That would be different than in series, like one's in front of the other. I think the parallel method is the best. You have a lot of valves in there so that you can shut one off so that when one breaks or you're working on one, the other one's still working for you. Because some hot water is better than no hot water, especially while you're trying to find a hot water heater and fix it over some weekend or some holiday. And the other advantage of a 50-gallon one instead of a 100-gallon one is that you can go get one at Lowe's or Home Depot or someplace a lot of the time, right? During the weekends and all these weird hours, different hours. Whereas a 100-gallon one, you're going to have to get delivered by these plumbing supply places, which are only open from like dawn to 3 in the afternoon or something on weekdays. So you're screwed, basically. So that's another reason for me to want to switch to the 50-gallon double heater configuration. So good luck. But you do it. At the heater itself, you've got this return line coming, which it used to be they were piped to the bottom of the heater, but apparently there's a new code where they want them to be piped to the top of the heater. So they go back into the cold input on the top of the heater. If that's the way they want it, I guess that's the way we're going to do it. Now, that cold water pipe goes into the water heater and it's supposed to have a plastic stick that releases the cold water down below so that it gets mixed properly. Although sometimes that thing breaks off and your water heater acts all crazy. And you can supposedly open it up there and you've got unions there, which is these things that you're supposed to have unions or something so that you can get the pipes off and on more easily. And in my experience, even though, the tank is made out of iron, steel, galvanized. So typically they come from the factory with a galvanized pipe on it, a nipple, a short pipe. And usually you see the plastic lining, which is part of that down tube, or it could be considered electrolytic isolation because dissimilar metals produce electricity and then they produce corrosion. Unfortunately, I've seen a lot of plumbers that I worked with in my own installations who've replaced all that with brass because they believe it's better. But the brass itself these days corrodes on its own. It's not like magic. It corrodes its own way. And it's not always a magic solution. So that's where some more controversy begins, because usually you're piping to copper. Although with the plastic everyone's using, that may save you a lot of trouble. But in my case, I've got to use copper. It's all big. I don't really make giant plastic. So I'm in a copper universe. So copper and the galvanized interact with each other, and the copper is the sacrificial. It's the one that loses material. loses ions. It's the one that rusts and shrinks or dissolves. So there is something called a sacrificial anode, which the water heaters come with, that ideally you could change periodically, but no one does it. And a lot of them, they don't make it easy, or they hide it, or you can't get to it. So these 100-gallon ones, you can't even get to it. It's pretty stupid. So the sacrificial anode is made out of a metal that's even more sacrificial, something like magnesium or something. So in lieu of that, I have put in a section of pipe near the water heater that is made out of galvanized metal, which is considered crazy by most people, but it dissolves and you see it rusting and you change it because it's easy to change. So you've made your own sacrificial anode. That freaks out all the plumbers because the code says, well, you're not supposed to connect copper to galvanized, but they're usually talking about big systems that are half copper and half galvanized. They're not talking about a little piece that's an anode. And then they'll say, well, why don't you buy a real anode made out of zinc? But that's some ancient thing they used to make, and they don't make it anymore, and you can't buy it anymore. So I make my own because it's physics, right? It's just first principles. I know it to be true. It works. I do it. But everyone will argue with you and freak out. But I do it. There's another way that helps is to add a electrically powered anode, which is plugged into the wall. And you can get them from Coroprotect. You can get them on the internet, on Amazon, and they're like, I forgot, $150, something like that. So they're available in like a 3/4 size, and they stick out like 2 feet or something. But usually they expect you to install it from the top in a home water heater that has an accessible anode as a replacement of the sacrificial anode. But in my case, on the 100-gallon unit, the only way I can install it is by cutting it off shorter and installing it from the side entry points, because usually there's extra side entry points other than the top ones that you usually don't have to use. So that I mean to do soon on one of my old ones. Also because removing the original anodes would be super rusted or corroded and potentially causing some problem where you take it off and you ruin the water heater somehow. So I kind of don't want to mess with the existing anodes that in my case, and some of the 100-gallon ones, I can't even access, and there's no way to do it anyway. But I would like to add on these electric ones, which are supposed to work really well. They have a 3/4-inch pipe size. But those are, again, the ones that you can easily get from Amazon whenever you need them. And no, they don't really seem to have them necessarily at the Macho Man official plumbing supply. But I think it's a good idea, and I want to do that. And there's another related thing you can get from Amazon, which is, I forgot the brand name, but it's called a mixer valve. And it works off, this one is like a 3/4-inch one, and it's about $200 or something. What it does is it mixes hot water and cold water. So therefore, you can turn your water heater up to a much higher temperature, and you can tap off that high temperature for your dishwasher and your clothing washer to kill germs. And then it also kills germs in the water heater itself. So it kills Legionnaire's disease and other non-tuberculosis, mycobacterium, and just all kinds of stuff. Cryptosporidium is in the water supply. It's really hard to kill. Like chlorine can't kill it. There's a little bit of it everywhere. There's just a lot of stuff, and you don't want stuff growing in there, and you don't want the stuff that comes in the piping system. And then you would like to be able to kill germs in your laundry and your dishes too. So you get this really hot water, and you'll have noticed it in restaurants. Sometimes you go into the bathroom and the water in the sink is just incredibly hot, dangerously hot, like you could hurt somebody. And that is because their mixer valve that they're supposed to have ain't working right or isn't hooked up or something. But you can buy one at Amazon in this 3/4-inch size for an affordable price, and you can put them on your 50-gallon water heater easily, right? So that's what I have used. It did go on the fritz after about 8 years or something, so I can order another one and fix it. But I did have to watch out because suddenly everything went haywire, and I had to go readjust it all on my thermostat, and I need to change it. And it probably got clogged with little particles. Possibly it will be able to be cleaned. Unfortunately, to buy the same sort of mixer valve for a 100-gallon water heater involves pipe sizes that are an inch or more, and the list price for the mixer valves for a 100-gallon water heater are $3,000 or more, and you have to order them specially. So it makes it another reason not to have
a giant water heater, and you're better off with the small ones that you can buy parts for 24 hours a day, almost from anywhere, all the time, and it's cheaper and it's easier. So I do think mixer valves are really cool. They are putting them now in shower valves and in a lot of faucets and stuff to try to keep people from being burned. But that is expensive, and it's not like you're going to change all the valves in some old apartment building right now, but you can put a mixer valve on the top of the water heater, and then you can run a hotter water heater, but have cooler water going to the faucets, but hotter water maybe going to the laundry machines in the apartment building. So that is another argument for 2 water heaters. There you go. Now, on the recirculation feature, which we were talking about, where the cold water returns to the hot water heater, that's a big problem because historically they've used these pumps from Grundfos and stuff that would just constantly pump all the way around. And what that would do is it would destroy your copper plumbing, and it would cause little teeny holes, especially near the elbows in the middle of the wall, that would just start leaking and cause untold horrible property damage. At some point, I said, to hell with that. I'd rather have everyone running water for a long time until it gets hot than having that happen. And it costs more money for the wasted water or whatever, but who cares? Water damage is just the worst possible thing, and you do not want it. So at this point, I don't use them, but sometimes they're attached. I'm not really sure whether that was just to satisfy some code junkie who comes along. But I also have pipes around them so that I can just pipe around them. That's especially true if things break. You'd like to have a pipe around them. And there's also usually check valves. By putting check valves in the recirculation system, they hope that the water will flow the correct direction. In other words, the hot water goes out of the big pipe on top of the machine and then returns on the cold side because there's a check valve saying it only goes one way. But those check valves fail all the time in other ways and become a nuisance. And so I usually have a pipe around there with a valve so that in case you just want things to start working again, you can open a valve and pipe around it. Or conversely, you can shut it, use the check valve and see what it's like. And so you can mess around with your check valves and your recirc pump if you want, but otherwise you can bypass them all. You also can put the recirc pump on a timer and maybe only run it like once in the morning or something just to heat up the pipes when you're pretty sure most people are going to work. And you do it just for a short period of time. It's another maintenance item, but there it is. Otherwise, if you run the recirc pump, you're basically running a hot water heating system, so your water heater is running a lot in the middle of the night as you just heat up the building for no reason. Oh my God. Hot water heaters are complicated, and there's a lot of stuff to think about, and I've probably forgotten something. I don't know. Anyway, good luck.